very warm welcome to InfosecTrain. Right. So my name is Ashish Dhyani, right? And I'll be the speaker for this webinar, right? And this webinar is for the youngsters about the cyber awareness because a lot of things are happening nowadays in the world. Lots of hack, lots of fraudulence, and many of the things are happening. So that's why we thought that we should go for a webinar to make the kids and the youngsters aware about what is happening and so that they can take like proper steps, right? So before starting the webinar, let me introduce myself. My name is Ashish Dhyani and I'm working as a trainer at InfosecTrain. So it's been decent amount of time that I'm working as a trainer and I'm in the field of cybersecurity, right? I have done lots of certifications related to cybersecurity. So in cybersecurity, you have certifications. So you have different sides in the cybersecurity, like you have the defensive side, you have the offensive side, the people who do the attack means hacking, find out that what problems are there in your software, and then the developers who are creating the software, they will basically patch those softwares, patch those problems in the code. And the defensive side people, they try to just detect that if someone is doing something malicious, so all those things. So I'm into the offensive side of the security, and I provide trainings to lots of people. So just to give you the information, because many of you might be new, like you might not be knowing about the training. So I give like at InfoSec Train, we give trainings to the professionals who are working, right? Working professionals in organizations who have lots of years of experience, who are working into cybersecurity or who are moving to cybersecurity. So we help all the professionals to work into cybersecurity and understand that what cybersecurity is, how to work, how to create the infrastructure and everything, right? So that's about me, right? Now this webinar that we are doing, right? In this webinar, we have an agenda, right? Many of you might have gone through the agenda, right? Let me just tell you that what our agenda will be for the days internet and digital world, right? So we'll see the basics that how internet works, what are the networks and the digital world, right? The data, right? What types of data are there, what information, how the data is from system to another. When I'm talking right now, how the data is, how you are able to hear my voice, right? So that will learn. Then I'll give you the introduction to cybersecurity. That what cybersecurity exactly is. We all have heard the name hacking, right? And hacking is what? Like it's just something which we think that we have hacked into Facebook accounts or Instagram accounts or any other accounts, but it's more than that, right? So I'll give you the introduction to the cybersecurity. Then in the cyber world, we have a lot of information. We upload lots of pictures. We have our digital identities. We have our social media platforms. So we'll discuss that how you can protect your personal identity, how not to be, not to give everything to the attackers about you. And then there are cases of cyberbullying, and so how you can report cyberbullying, what is cyberbullying, the etiquettes that, right? What scams are going on nowadays. So I'll give you, I'll put light on that as well. Then what is ethical hacking? How ethical hacking is done, right? So there is a small practical I have kept for you guys so that you can understand how we uh, basically hack, right? Into things. Let's say there is a mobile phone, so how we hack into Android, right? So that's what we'll be looking into, and a procedure, right? So the procedure is known as penetration testing. So that procedure will be looking into that why we do penetration testing, how it is done, and how it helps the organization to stay safe, stay secure, right? Then we all have, like, you might have heard about cloud, right? So cloud computing. So cloud computing will be looking into like how cloud computing works, what is cloud computing, why we need that, and why the world is moving towards it. Then we have SOC. Now, SOC stands for Security Operations Center. So this is a place in the organization which works into the detection part, into the blue teaming side, into the defensive side of the security, right? So we'll see that how these people work, right? Now, for the day one, we have the agenda that what is network, then what is internet, right? Then we'll discuss about the data, right? And data transmission models and the networking devices as well, right? So this will be our agenda, right? Every day from 4 to 6 we'll be discussing all those things, whatever agenda we have discussed, right? And the first thing that we have is network, right? Now when we are communicating with each other, right, there is a network created, right? Even without network, we won't be able to communicate with each other. Yes, there is. So you might be connected to a device which is known as router. You are getting internet at your home, right? You browse to different websites. You clicked on a link, and using that link, you joined this meeting, right? This meeting is a place where we all are connected to. Now you can hear me, right? So whatever I will be telling you, you can hear me, you can understand that what things are happening. So there is a network between us. Even when a group of people are communicating with each other without any uh, so when we are talking about network, in simple terms, we can say that network is a collection of devices, right? Collection of devices communicating with each other, right? Now, when we are talking about that, it is a collection of devices and which are communicating with each other. So, for creating even the smallest network, how many minimum? So, what you do, you basically communicate. Let's say there is your device, you have a computer, right? And you connect your mobile phone to your computer using data cable. Is that a network created? Yes, that is a network created. Now, many of you might play games, right? So there was a very famous game among youngsters. It was with the name PUBG, Player Unknown Battlegrounds, right? So what that game is, that is also working on a network. So you have 100 opponents, like 100 people in the whole game, and if all of them they have like they are four or in the team of four, right? And then what you do, you are in a place in a field, and then you are running, you are chasing others so that you can get that chicken dinner, right? So how it is working basically? This is your device, right? And you are playing in that game, right? So you shot a bullet. That bullet went to some place, and that place is your opponent's device, and your opponents got shot. How that happened? So whenever you are sending some data, that data is sent through the devices, right? You have networking devices in between, right? So how you are getting internet? So there will be a box at your home, which is with the name, which is called router or router, right? Now that box is giving you the internet, but that box is connected to other boxes that are there over the whole world, right? So once you are once you are clicking on your mouse and it shot a bullet. So bullet gave a signal and that signal went to your router. From your router, it went to the next router, right? Somewhere else, right? Then some other router. And from there, it reached the server of the game, right? The game server, right? So game is placed in a server. Now, what is a server? Server is something which gives you services. It serves the purpose. It serves you, right? So you ask something from the server, server will reply you back, right? So that is server. Now your request went to the server and the server sent that request again to other devices over the internet, right? So it went to other routers and at last it reached the router of your opponent, and then your opponent device got shot, right? Not the device, but your opponent got shot. So your opponent device got the signal and it got shot. So that's how it works. So this is what, even your opponent is sitting in, let's say, USA, and you are sitting in India, right? Even then, this whole thing happens, right? And this is a small part of a network again, right? This is just a small part of the network. So in the network, there are billions of devices interconnected with each other. Yep. So this is known as network. If there will be no network, you won't be able to communicate with each other. You might have seen the landline phones. So landline phones, they have what? They have wires in them, right? So they are connected through wires. So if they are connected through wires, you are talking to someone, so your voice is traveling through wire and it is reaching your relative or friend whom you are talking to. That is what? That is network, right? Great. So I hope there are no doubts in this. Now, after network, the next thing that we have is types of network, right? So we have different types of network. We have divided the network into different types, that what kind of network it is, right? So we have personal area network, we have local area network, we have metropolitan area network, we have wide area network as well. So how we have divided these computer networks? We have divided these computer networks on the basis of this area, right? How much area it covers. So personal area network is one which is the smallest one. It covers the smallest area, right? How? Personal area network means your personal devices are communicating with each other only, right? Now it can be your laptop connected to your mobile phone, right? That is also a personal area network, right? Now, personal area network covers only very less amount of space. Like you can say it's on your table only, nothing apart from that. That is personal area network, right? Then we have local area network. So when we are talking about local area network, it is what? It is a group of computers and devices which are sharing common communication line, right? Why we create network? What is the need of the network? It is communication, right? I want to share songs, right? I want to share games, I want to share some files, right? Some documents, right? So how I will share it? There should be some communication medium in between, right? So that is why we need network. So when the devices they have a common communication line, right? It is known as local area network. Now, when we are talking about local area network, so what we see there, let's say there are devices. Um, so this is one device, this is other device, device 3 and device 4. So all these devices are connected to this single line, right? This is also a local area network, right? So PC1, PC2, PC3, and PC4 are there. So PC1 wants to send some data to PC4. So PC1 will say that I have some data for PC4. Let me send it. And PC1 will send that data to PC4, right? This is also local area network. Then if I ask you a question, let's say I'm in a building, right? So there is a building. In that building, we have what? We have this is ground floor, first floor, second floor, right? So if I have some devices on ground floor, some devices on first floor, some devices on second floor, right? Will I call it a local area network? Yes. So this will be a local area network. So if we have all these three connected with each other, right? It is a local area network because they are in the same building. So the network in the same building will also be called local area network. Now, local area network can be wired and it can be wireless also. So, wired means that you have a device, right? So, you might have used that sometimes you are not using router, but the Ethernet cable you directly connect to your computer, right? There is a port which looks something like this, right? This is Ethernet port in your device, right? So you directly connect that cable to your device so that internet will work in your device. So that is example of wired network. Nowadays we use wireless network. So you use Wi-Fi. Everyone knows Wi-Fi, right? So you open your Wi-Fi and you connect to your router and you start using the internet. That is also a kind of local area network, right? So that is called WLAN, wireless local area network, right? So you might have experienced that whenever you are connected, your mobile phone is connected to your router, right? So what happens? You are getting internet, but if you are moving away from your router, so the signal strength starts degrading, right? Your internet starts becoming slow, and after an extent, you don't have any connection. You are disconnected from that router, right? So router does what? Router just covers some amount of area, right? And it can be 30 feet, right? After 30 feet, you will get disconnected. That is again wireless and wired local area network. So the first thing, that you don't have to purchase separate internet connections for every device. Yes. So let's say you have 5 devices. So from those 5 devices, you can just create a local area network. Like you can just purchase a router, deploy that router, and then after that, all the devices can use same internet connection, right? That is one advantage or benefit, right? Then you can protect your devices, right? So all of your devices are in the same network, so you have to purchase a single security solution, right? Let's say you don't want anyone else out of your network to access your internet, right? Let's say I have 5 devices, right? And from those 5 devices, I want only these 5 devices will be able to access the internet, but no one from outside will be able to, should be able to access the internet, right? So that is what? That is, again, one security concern, right? I don't want anyone else, or I don't want to share my internet with anyone. So I will put a password there, right? So I will set a password. Only the devices which have the password will be able to access the internet, right? That is another thing. Yes. Now you have types of local area network. So in types of local area network, you have peer-to-peer LAN, and you have client server LAN. So what is peer-to-peer LAN and what is client server LAN? So in peer-to-peer means that you are directly connected. There is no one in between for the management, right? Like you have your laptop, right? And from your laptop, you want to send something to your desktop, right? So what you will do, you will connect it using a wire. So one end of the wire will be plugged into your laptop, other end will be plugged into your computer, and the sharing of data will be started, right? So that is what? That is peer-to-peer LAN, right? Then we have client-server LAN. Now client-server LAN means there are different devices, but all those devices are connected to a single server. Yep. So what switch will do? Like there is server in between. So this is one device, this is other device, this is device 3, and this is device 4, right? And there is a server in between. So all the devices are connected to the server. So if anyone wants anything from anyone, let's say PC1 wants some file from PC3. So they have to ask the server that I want this file from PC3. Then the server will go to PC3 and will say that yes, PC1 wants this file from you. Just give it to me. I will give it to PC1. And then it server will get that file from PC3 and give it back to PC1. Right? That is what? That is client server local area network. Now, now metropolitan area network is what? It is the network which interconnect the cities, right? Or within a city. right? So let's say you are in India and you are sitting in Delhi, right? And you want to communicate to someone who's like, yes, you can call them anytime, right? So that is what that is metropolitan area network, which is making it possible so that you can contact them, right? Now, metropolitan area network, it has a range of 50 to 100 kilometers. So if your target is 50 to 100 kilometers away from you, then it is metropolitan area network. Let's say I'm sitting here, I'm sitting in Delhi, someone is sitting in Mumbai. So it is more than 100 kilometers, right? So that won't be metropolitan area network, but that will be different network, right? Which is wide area network that we'll talk about, right? Now, in between all these networks, there is a network which is CAN, right? Now I'll tell you what CAN is. So CAN is campus area network, right? Now campus area network is what? In colleges, what we have like different places, different buildings, right? Let's say there is a building. This is technical building, right? This is your medical building, right? This is your management building, right? So there are different buildings. All these buildings, they might be having some devices, right? So technical building would be using computers. Then in medical building also there will be some computers. In management building also there will be some computers, right? So how to manage them? So if you want to manage them, you just have to create a network there, right? So there will be a room that I will create. It will be with the name server room. So all the devices of every building will be connected to the server room where there will be different servers running, and those servers will be managing the devices, right? Now, if they are managing, right? So the campus is big, let's say, right? So the servers are managing all the devices inside. Now it is bigger than personal area network, it looks like. But why don't we call it local area network? Rather, we call it campus area network. So I told you that local area network is what? It is within the building, right? But there are different buildings which are getting connected. So it is bigger than local area network, but it is smaller than. Great. Then we have wide area network. Now wide area network is the biggest one. It covers. Okay. So the biggest network in the world, internet. It is also kind of wide area network. Wide area network has billions of devices connected. So the internet that you are using, you are able to communicate with each other. So that is wide area network, right? So all these personal area network, local area network, campus area network, metropolitan area network, all these are the part of. Yes. So when you are accessing google.com, So your request, you are sending the request to the server of the Google, and server of Google is giving you the Google page, right? So the whole process is happening going from your device to other device. That is what? That is again wide area network, right? And if you add, I have added the domain name. So everything is wide area network, and if you add like the domain name with it, right? When we are adding websites, it becomes GAN, Global Area Network. Perfect. So these are the types of networks that we have. Okay. So we have internet, right? So one internet is this with uppercase I, and the second internet is this with lowercase I, right? So the internet with uppercase I, this is the one from where you download movies, the whole www. This is the World Wide Web, right? From which you download movies, songs, or any file you send, you receive, you send emails, everything, you are browsing websites. So whatever you are doing with the help of this internet, right? So always write internet with uppercase I, right? And when we are talking about internet with lowercase I or small I, right? Then what is internet? Okay. So the internet with lowercase I, it is for interconnection of devices, right? This is created when minimum two devices are communicating with each other, right? So it is not even in the building. Like local area network does what? It covers the building, right? Internet with lowercase I, it's like personal area network only. Now, when we are talking about internet, so we should know that how the internet is working, right? So how it works? We have internet provider, right? We get the internet from some internet provider, like we have Geo, we have Airtel, right? So that those are what? Those are internet providers, right? From them, we are getting the internet, then we are able to access it. But back in the back end, what is happening? How the data is getting transferred? Yes or no? So we should know that how it works, right? So here, if we you can see in the image, what we have a device, right? Computer. From there, we have a satellite, right? Satellite antenna is there. There is GPRS, Ethernet, right? So whatever way you are accessing the internet, and how you are getting it, you are getting it in your GPRS dial-up Ethernet or in satellite. modem from the help of internet provider. So internet provider can give you internet wirelessly or wired as well. So what we have in internet, let me tell you. Whenever we are talking about internet, so internet, the full form is inter networking, right? And networking means there is a network created. Yep. So what we have packets, right? In network, we have packets, right? So packet is what? It is a small segment of a larger message. So if I'm sending hello, how are you, right? So I'll create different packets for sending. First packet, second packet, third packet, and fourth packet, right? So these are different packets that I have created. So packet contains what? It not only contains data that you are sending, but information about the data as well, that what kind of data it is, right? And the information of the packet or the information of the data goes in header, right? So information about the packet content is known as header. So it goes at the front of the packet so that the receiving machine knows what to do with the packet, right? So you can think of it how some consumer products come with assembly instructions. But like you may purchase some things like any convertible stuff, right? Anything you ordered from the internet. So there are instructions with it, right? A booklet arrives with it, right? And that booklet has all the instructions that how to use it, how to uh, connect all the parts of this device and everything, right? So that is what? That is a header of the packet, which has all the information, right? So when the data is sent over the internet, first it will be broken into smaller packets, right? Then those packets will be converted into bits, right? Bits means combination of 0 1 0 1, right? So we have known that computer understands machine language, right? So it contains 0 1 0 1, right? 0 means off or false, and 1 means on or true, right? So it understands the data in the form of bits. So that's why the data is translated into bits. Then using different switching and routing devices, networking devices, the packet will be sent to the destination. When the packet will be sent to the destination, the receiving device will combine all the bits, all the segments, and then it uses it to display the data, right? Now, with packets, one more thing is used when you are accessing the internet, which is protocols. Now, when we are talking about the protocols, I can say that protocol is a set of rule which we need to follow, right? So if I write protocol here, so it is set of rules that your packets follow to reach the target, right? So let's say you have two computers, you are connecting two computers, right? Both of them, they have different hardware, they run different software, and even then we want both of them to communicate with each other, right? So that was one of the main challenge of the creators of internet, that how we can make all the devices communicate with each other even if they have different build or they are running different softwares or operating systems. What we can do, right? That was the problem that they had to solve. So they will need some communication techniques that will be understood by all the connected computers, right? Like two people, right? So what we have, let's say two people who grew up in different parts of the world, right? So they don't understand each other, but we have given a protocol that you have to speak in English, right? So now both of them, they know English, they will start communicating in English, right? That is protocol, right? So what is the use of protocol? You are using protocols for sending packets between the devices on the same network, right? Now, protocols, they make sure that uh, your packets which are being sent, they arrive in order, and they are also responsible for formatting the data of the for the websites and applications, right? So that is protocol. So we need packets and protocol. So what happens? Uh, this is a packet. It has some header, some information, maybe some trailer as well, and I'm sending the data hello. So that hello will be sent, right? And the information about hello, who sent it. So you need IP and MAC address of that person, right? Who is sending it and who is the receiver of it. The IP and MAC address both, right? And then what if something happens, right? While you're sending the data, the may something happen, right? So that is trailer. So this part in the packet is known as trailer, and the first one is known as, this is header, right? So header and trailer, they are the part of the packet. So client server model is what? It is something, a structure which uh, does what? It does the partition of task between the providers of resource and the service, right? So the service clients, right? Or you can say the requesters. So these are called clients, right? From whom they are requesting, right? The provider of the service. They are called servers, right? So we have clients and we have servers. So clients do not share any of their resource, right? So you have emails, you have World Wide Web, you access them, right? So how your data is being transferred? You're writing an email. That email is sent to, let's say you are using Gmail, right? So your email is being sent to not directly to the person whom you are sending it, right? But it is being sent to the Gmail server, right? And when you are sending it to the Gmail server, then from Gmail server it is being sent to the target, right? Let's say you are sending an email to me, so first it will go to the email will be sent to the Gmail server, and from Gmail server it will arrive at my email in my inbox, right? So client server model is there because there is a centralized management need, right? There was a need of centralized management, right? So this server does what? It does the management, which is known as centralized management, right? Now we have to know that how this client server model works, right? So when we talk about the word client, it means to talk of a person, any organization which is using any particular service, right? So in the digital world, we have client. So the client is the computer which is able to receive any information, right? And then we have servers. So when we talk about server, so any person or medium which serves something, right? So same like in the digital world, server is a remote computer which will provide information to any particular service, right? Whether it is allowed or not. So client is requesting, let's say, something from the server, and as long as it is present in the database, server will give it back, right? Now, your browsers that you have like Mozilla Firefox, Google Chrome, how they are communicating with the server. So you enter the URL. Yes. Once you enter the URL, right? Then after that, from the URL, you will need the IP address of the target that in which network it is sitting in, right? So IP address is what? IP address stands for Internet Protocol Address, right? And that Internet Protocol address does what? It tells, it is also known as logical address, right? So it tells that which network your target belongs to, right? After you have found the IP address, then your browser will send a request to the web server's IP, server send the necessary file of the website, and the browser renders the file and website is displayed. So the rendering is done with the help of, like, there is one thing called document object model interpreter. So whatever code was there in the server, the code gets executed and you get the page of the website in front of you. So advantages of client server model is like there is a centralized system. So all the data will be in a single place. Data will not sprawl here and there. So no one else will be able to get the data. You are able to access the data for which you will give username and password only, right? Yes. Then it is cost efficient. Now, whenever you are using something, you need to know that it is cost efficient as well. Now, how it becomes cost efficient? Because it has less maintenance. Yep. That's why client server model is cost efficient. Now, if I ask the disadvantages, right? So clients are prone to viruses. So if there is a virus in the server and I ask for some information, so my device will also be infected with the virus, right? Then there can be different attacks, right? Anyone can change the data, right? The data that you are sending from client to the server, in between someone can intercept and get the data. Yep, great. Now the next one that we have is peer-to-peer network, right? Now what is peer-to-peer network? How will you define that? So in this image, we can see that there is no server in between. So the communication will be done directly, right? So if one device, this device one wants to communicate with the other device, so it will directly send the data through this link, right? If this peer wants to like wants to communicate with peer 4, right? Let's say this is 4. So it will be directly connecting to it and the direct communication will happen. So that is your peer-to-peer model. So everyone might have used torrent, right? Now torrent does what? Torrent helps you to download, like there is BitTorrent and uTorrent. So torrent helps you to download movies, but the internet speed is very slow, right? So there are two words that are used in torrent. There is seeding and there is leeching. Yep. So the bandwidth of the connection in peer-to-peer model, it depends on the number of devices that are online, right? If there are less number of devices that are online, so the bandwidth will be less, right? Everyone's internet, everyone's bandwidth is used while you are accessing the peer-to-peer model. You are able to, or you are trying to do that. So torrent does what? Torrent has lots of peers, right? Let's say. So from the nearest peer, let's say this is device one. I'll ask device two. Do you have this movie that I haven't watched? So if you have that, just send it to me. So the other device will send that data, right? Now, seeding or leeching, it depends on the number of devices which are online. So if I'm online and I'm downloading something, so I'm using the bandwidth of other devices which are online and using the same software also. Seeding, right? Now in seeding, there is like after seeding, like you have downloaded the movie, your work is done, and you closed that application, let's say torrent. That is leeching, right? Leeching means that once your work is done, you are not helping others to increase the bandwidth, but you left. Now, nowadays, who uses that? Spotify. Everyone has used of Spotify. Everyone knows Spotify, but no one knows that it also uses peer-to-peer model. Yeah, it uses client-server model as well, but it uses peer-to-peer model. So the nearest device which will be having the same song that you want to play, your mobile phone will be connected to it. Yep. So this is our peer-to-peer model. Now, the next thing that we have is data, right? We learn security because we have data, right? And we have heard that data is the new oil, right? So we want to protect that data from the people who can misuse it, right? Now, what the data can be? It can be any kind of data. Let's say you have your uh, debit card, let's say, right? So do you want anyone to get that debit card information? No, right? So you don't want anyone to get that information. That is also data, right? Now, if I show you one thing, uh, if you see, there are lots of debit card information, right? This should not be there. You should not get anyone's debit card information, but it is there, right? So that's why we need to protect the data. But when we are talking about data, there are three things, right? There is one other thing which is known as data and information. Now, what do you think? Is there any difference between the data and the information, or both of the things are same? So data is what? In raw format, we call it data, right? Information means we make something informational, right? Or we are finding out the meaning of the data. We are just manipulating the data. We are doing the segregation in the data, that what things we need, what things we don't need, right? So that is what, that is your information. From raw data, you are creating some information, right? So it can be measurement, quantities, numbers, facts, informations, graphs, anything, right? So when we are talking about data, we have data classification. So we need to classify the data as well. Now for classifying the data, what we have public data, we have internal only, we have confidential and restricted also, right? So public data. Now public data is what? Any data that is freely available to the public, right? So you have price list, any company you pick up which sell any type of products, right? So you will get to know, like you pick up Samsung, right? Samsung just gives the price list of every mobile phone. It does not hide it, right? So that's why it is what? It is again public information, public data that is available. Then we have internal only. So internal only means there is a there is any company, let's say InfosecTrain. So whatever data is related to InfosecTrain, which only information InfosecTrain employees will need someday, right? That data is internal only. So it is not meant for public disclosure. When we are talking about confidential data, it is the sensitive data. If it is compromised, it will negatively affect the operations, right? It can do anything. Like what we have, uh, let's say there is the organization, and in that organization you have lots of information about the employees and everything, right? And there are people working as well. So one of the working professionals, their username and password got hacked, right? You have seen that you have Uber, you have Ola, you book taxis and everything, right? What if you get the information of any user, right? The login information of any user, right? So you will log in. Let's say you got my information, right? So you will log into my account, and once you log into my account, you can freely you can just travel anywhere, right? You can book Uber and from my account, and you can just travel, right? So that is what, that is again confidential information or sensitive information, right? Then there is restricted information, right? Now restricted information is what? Very sensitive corporate information like IP, credit card information, social security number, or any personal health information that should not be given to anyone, right? Like I have my personal health information. I did some I had some checkups, and in those checkup, right, that data I showed to the doctor, but the doctor should not show that information or that whole report to anyone else, right? Only I should be able to have it, right? And the doctor should be able to know it. So that is restricted information, restricted for only the people, the only the, like if I talk in terms of the organization, so only the people, the high end people, the C-level executives only, right? No one else apart from that, right? That is restricted data. Now, next is types of data. So, in types of data, we have sensitive data, we have personal data. Then the intersection of sensitive data and personal data becomes private data. So, private data is some part of sensitive data, some part of personal data. Now, sensitive data is what? When we are talking about sensitive data, so it is not already public, and if it is disclosed, it may harm the organization, right? So what things will be there in sensitive data and personal data? Now, when we are talking about the sensitive and the personal data, right? So sensitive data is the special category, right? So it is what? It is a personal special category of the data, right? And that sensitive data should be processed properly, right? So it needs greater level of protection because it is sensitive, right? And if you have given the consent, right? How you access the sensitive data? If you have given your consent, explicit consent that yes, you can access the data, yes, you can work with the data, only then anyone can take that data, right? Otherwise, no one else can take that data, right? Personal data is any piece of information which can be used to identify someone, right? If I want to identify you, right? So that is what? That is your name, your surname, your email, your location data, your IP address, your home address, right? That is personal data. Now, personal data is governed by data protection and the regulations. So there are some regulations that we have to follow. That if you have the data of any of your customer, let's say uh, we give trainings, right? So we have the data of our students, right? So when I have the data of my students, I cannot share it publicly. Otherwise, I may face some problems. Now, the next thing. We got to know that what kind of data is there. We got to know that there is a peer-to-peer model, internet, how internet works, the network types. But why we learned all of this? To get to know how the data is transferred. So if you will get to know that how the data is transferred from one device to another, only then you will be able to understand that why we need security and where we need security, right? So the very first thing that we have is the OSI model and TCP IP model. Now, OSI is the model which stands for Open Source Interconnection Model, right? So now this model is a reference model, right? It is used as a reference. We are not following it, but it is a reference model which tells how the data is transferred from one device to another, right? So there are 7 layers in this model, and every layer has its own working, right? So this is layer 1, this is layer 2, layer 3, layer 4, there is layer 5, there is layer 6, and there is layer 7, right? All these layers, they have different working. Now the layer which is closest to the user, it is application layer, right? Because that is the only thing user can see. Right now, if I ask you which layer is closest to you, so it is application layer because you are able to see the things. So you don't know how the voice is coming to in your headphones and how you are able to see the picture of my screen. But you have what? You have GUI only, right? Great. Now, when we are talking about application layer means GUI. GUI means graphical user interface. So whatever you see in front of you, whatever you are able to see on your screen, you are clicking. That is application layer for you, right? Now, application layer does what? Application layer just shows you the thing, right? Let's say I'm sending you a message on WhatsApp, right? So what it does, it basically WhatsApp shows you. But how that message is traveling to your device, you don't know, right? Then there is one layer, the layer number 6, which is presentation layer. So what I did, I wrote a message to you, hello, right? At application layer. Now I want to send this data to you. So for sending it, I have to make sure that no one else read this message apart from me. Yes. So what we do, we send our data to the presentation layer, and presentation layer does what? It does the encryption of the data. So it encrypts the data. Now what encrypting means, what encryption means? Means changing the data into unreadable format, right? So if I write like this, so I'll be encrypting the data so that no one will be able to understand, right? This happens at the presentation layer. After presentation layer, session layer is there. Now session layer does what? It takes cares that whom you are connecting with. Let's say you want to send data to me, you want to connect to me. So at that time, what will happen? A session will be created between you and me. Otherwise, the data might be sent to anyone. So you should know that with whom you want to communicate and to whom you are sending the data, right? So session will be created. Now let's say you are sending mail, right? So there is Gmail. So the sender device and the Gmail server both have a session going on in between, right? So the sender will send the data to the Gmail server. Gmail server will forward that data to anyone who is intended, right, for sending the mail. Then there is transport layer. So I told you about packets. Yep. So what happens? Your transport layer, the work of transport layer is to do the segmentation of data, right? So it will create segments. So segmentation means that if I'm sending OEHLL, so will all will be in different segments, right? So all this hello word, it will be in different segments, and one by one the data will be sent, right? Now next thing I want to know, like whenever you send any letter, right? You wrote the letter, you put it in the envelope, and you send it directly, right? Don't you write the address? Yes, you also write the address there. Yep. So that is what? That is the work of network layer. Now network layer does what? It adds IP address to your data. IP address, Internet Protocol address, that means your uh, logical address, right? So it will tell, like if I'm sending, it is something like it will tell the network, right? So if I say that I'm from Delhi, right, and you write a letter to me, so you will write to Ashish in Delhi. Will that letter ever reach to me? No, it will never, because there are many people in the same city with the same name. You have to specify. But you got to know that I am in Delhi, right? That is my network. That is my logical network, right? Logical address, Delhi. But if I want that you have, like you want to send me the letter, you need a specific address, right? The home address, the house number, the street, and everything. So that is what that is known as MAC address. And the data link layer, it gives you MAC address, right? Now MAC stands for Media Access Control. So this is the address of your network interface card or network card that you say. right? It is the address of network interface card. So this MAC address, it is known as physical address of your device. It tells where physically your device is present right now, right? And then we have physical layer. Now physical layer does what? It converts the data into bits. That means a combination of 0101. So it will convert it into bits on the basis of the medium that you are using. If you are using a wired medium, right, through a wire you are sending the data, it will be converted into bits. Otherwise, radio frequency it will be converted if you are using wireless, right? That is physical layer. So this is the work of every layer in the OSI model, right? And that's how your data is sent. So once your data has the IP address, MAC address, and then your data has uh, is encrypted, right? Then your data is sent to the target machine, the physical layer of the target machine, right? Now once I send the data will be sent to the physical layer. The physical layer will again convert it into digital or analog, right? Once your data reaches the physical layer quickly converts it so that the other layers can understand the data, right? Once it converts the data reaches data link layer. Now in data link layer, what we have the MAC address, right? So we added the MAC address from the sender side. So in the receiver side, the MAC address will be checked if the MAC address written in the desktop, right? In the data. So if that data is matching my desktop or my device's MAC address or not. If it is matching my device MAC address, then the data will be accepted. Then in network layer IP address was added. So it will check if IP address was uh, written in the message. Is it for me or is it for someone else? So it will check the IP address that if it is correct or not. If it is correct, then the data will be accepted. Then the data will reach the transport layer. In transport layer, before segmentation happened, now assembling will happen. So all the packets, how many pieces you have done to your data, so all those pieces will be combined together, right? And then after combining, it will be sent to the session layer. Layer will get to know that the we have to close the session, and then it will be sent to presentation layer. Presentation layer will just put the data in unencrypted format, right? Once it is unencrypted, then it will send it to application layer, and in application layer you are able to see that what message your friend has sent, and your friend has sent in hello, right? This is OSI model and this is how it works, right? Now, same like OSI model, we have TCP IP model, right? But in TCP IP model, there are less number of layers. So what happened? OSI model was like it's not older than TCP IP model, right? TCP/IP model came first, and it was implemented in the whole world, right? Then after that, OSI model came, just for the reference. But OSI model was not able to tell properly about the protocols that will be followed in each and every step, right? And sometimes there are sometimes when you don't need many of the layers also. Some of the layers don't work in some kind of communication. So that's why TCP/IP stood there and it is still working same, right? Now in TCP/IP model we can see that we have application layer, transport layer, network layer, and network access layer. Right. So application layer, it is application layer, presentation layer, and session layer. Now we have transport layer, it is as it is. Same. It will do the segmentation of the data and it will send the data to the next layer. Now network layer is there, right? In TCP/IP model, sometimes you will see it is also called internet layer, right? So this network layer or internet layer, it will add the IP address, right? Perfect. Then we have network access layer. Yep. Now network access layer is what? It is a part of a combination of data link layer and physical layer, right? So data link layer does what? It adds the MAC address. Physical layer will convert the data into understandable format, right? So that is what? That is your OSI model and TCP/IP model, right? So when we are communicating with each other, right? We need devices, right? So when we need devices, so what all devices mostly we use? So we use repeater, we use hub, right? We use bridge, we have network switch, we have modem, we have gateway, we have access point, right? Everything for communicating. Great. Now, when we are talking about the devices, let's say repeater first. What is a repeater? How will you define this repeater device? The repeater does what? It repeats the signal, right? So whenever I'm sending data, my data is traveling in the wire, right? From here I send the data, my data has traveled 100 meters. So after 100 meters, my signal will start degrading, right? And the receiver won't be able to hear my voice. So then what we do, we use a device which is with the name repeater here. So once it repeats the signal, the signal will gain its strength back, right? So it is a kind of you can say amplifier. It is working as an amplifier which will amplify the signal strength again, and signal will be able to move 100 more miles. Then we have network hub. What is hub? Hub is a device that connects multiple wires from different branches. It is used to connect multiple computers with each other in the same network, right? So that you can send data to each other. So let's say this is one device, and this is your other device, and the third one. and this is the fourth device. So if I want to connect all these devices together in the same network, I will use a hub, right? So that is hub. Then we have bridge. Now bridge is what? Remember I told you about local area network, that there is a building and there are, in the building there is first floor, second floor and ground floor. Remember this? So in this, you have some devices at the second floor, on the first floor, on the ground floor, right? So what you will do, you have, why I said it is a local area network, because it has connected all the devices in that organization through a bridge. So bridge does what? It joins any two different segments together, or two different networks together. That is the work of bridge, right? Then we have switch. Switch is also a device which is used uh, like hub, but it is more intelligent as compared to hub. Hub does what? Hub will broadcast the data. That means if I'm sending some data to you, now the data PC1, PC2, PC3, PC4. So PC1 is sending some data. That data is being broadcasted in the whole network. Think of it the same way that you are sending some message to your friend and that message is broadcasted or sent to all the contacts in your mobile phone. Will you feel good? No, absolutely not. Right? So that is a broadcasting happening. So what I did, right? Instead of using hub, I use switch. And in switch, you don't have broadcasting feature, right? So you can connect different devices and give their MAC addresses to the switch, right? So the switch will do what? Switch will send the data into a specific place to a specific device only, right? Let's say PC1 is sending data to PC2, so the data will be sent only to PC2. It will not be broadcasted to PC3 or PC4. Yep, that is switch. Then we have modems. So it's been a long time that we have used modems, right? So modem stands for modulator and demodulator, right? It modulates and demodulates the commands. So what it does, it converts the digital signals into the form of analog signals, right? And from analog to digital. So that is the work of modem, right? Then there is gateway. Now gateway is what? When we are talking about gateway, you can say it is a path or a place where two networks interlink together, right? So I'm sending some data, right? I gave you the example as well that I'm sending some data, right? This is my device. I'm sending some data. So that data went to my router. So inside router, we can call my router a gateway as well, because this is the path which will open the door for me and my data will be out in the public, in the uh, website, or like anywhere I want to send that data, right? So that is the first door that opens, right? That's why we call it gateway. And then we have access point, right? So access point is what? Access point is the appliance which operates on the OSI model second layer, and access point allows you to connect the wireless or wired network to a wired network, right? So can I call my router as a access point? Yes, I can call it. I can make it work because it is giving me the internet, and that is the point which is from where I get connected to the internet. So that is access point for me, right? So these are some of the networking devices that we use, right?